Okay, on this video we are going to start solving the same differential equations, but trying to find the particular solution. Now, remember that we may have this differential equation in the previous videos. It was equal to 0. That means that the general solution was composed only by the homogeneous solution. But because now we have something here is not 0, then we have to find the particular solution. So in this video we are going to talk about a method to find this particular solution. And the method is, the name of the method is undetermined coefficients, right? Okay, so this q of x is not 0, so let's start with some examples before I give you the name of the undetermined coefficient. So let's assume that it is equal to 4x plus 5. It's a polynomial. Okay. What we are going to do first is find the homogeneous solution and then find the particular solution. So the homogeneous solution is going to be something like this: second derivative minus 2 first derivative minus 3y equals 0. So this is the homogeneous differential equation. The characteristic equation is m squared minus 2m minus 3 equals 0. Now think in two numbers in which the multiplication is minus 3 and the addition is minus 2. So I may think it is plus 1 and minus 3 equals 0. So the multiplication is minus 3 and the addition is minus 2. Okay, so from here I can see that my first root is equal to minus 1 and my second root is equal to 3 positive. So the homogeneous solution, it is equal to c1 exponential of minus x plus c2 exponential of 3x. So here you have the y1 and here is the y2, and this is part of the homogeneous solution. Okay, so we have found this part, but now we have to find the particular solution for this differential equation when it is not equal to 0. Okay, now this method says that the particular solution should be something similar to the q of x. So let me write that here. The particular solution, the yp, is similar to the q of x. Okay, so what we have to do is, because the q of x here is a polynomial, then my particular solution should be a polynomial. It doesn't make sense to have a natural lorem, because this is not a natural lorem, or exponential, or a tangent of x. So the particular solution must be something similar to q of x, because you are going to replace the particular solution here, and it makes sense that to have a polynomial as the particular solution should make sense to be equal to this polynomial. So that is actually the method, but because we don't know which polynomial is going to be the solution, so we have to do this. The particular solution is equal to this polynomial. The polynomial is, the power is 1, so the degree is equal to 1. So I'm going to propose a particular solution of the same degree. So I'm going to make ax plus b. And this is the proposed particular solution. Now, from here comes the name of the method. We don't know what are these values, these coefficients, so that is why we have to determine those coefficients. So the task here is, to find a and b. Okay, so let's do this exercise. So if this is the particular solution, then if I replace it in the differential equation, then that replacement should be equal to 4x plus 5. Okay, so let's do it, and this is very easy. We have to find the first derivative and the second derivative out of this. So the particular solution first derivative is going to be just a, and the particular solution second derivative is just 0. Alright? Derivative of this is a, and the derivative of a constant is equal to 0. So now let's replace in the differential equation. If we replace in the differential equation, so my second derivative is 0, and then minus 2 my first derivative. My first derivative is just a, and then minus 3. The proposed particular solution is going to be ax plus b, and this is supposed to be equal to 4x plus 5. Okay, so don't miss what we have done here. This is the particular solution second derivative, this is the particular solution first derivative, and this is the particular solution, and this configuration is the differential equation. So now what we have to find is a and b. What are the values of a and b such that this is equal to this? Okay, so let's continue. So from here I can see it is minus 3ax, alright, and then minus 3b from here, and then minus 2a equal to 4x plus 5. Okay, so what we have to do is to make equal the coefficients. So for this polynomial to be equal to this polynomial, what should happen is that this coefficient must be equal to this coefficient, and this coefficient must be equal to this coefficient. So that means that minus 3a shall be equal to 4, and minus 3b minus 2a must be equal to 5. So from here I can see that the value of a is minus 4 over 3, and let's replace that here to calculate the value of b. The value of b is equal to this to the other side, and the minus to the other side is going to be 5 plus 2a divided by minus 3. And let's replace the value of the value of a. So it's going to be 5 plus 2 minus 4 over 3 over minus 3. So what is the value of this? 5 minus 8 over 3. 2 times 4 divided by minus 3. This 5 in thirds is going to be 15 over 3. So that makes it, so this is 8. So 15 minus 8 is going to be 7. 7 over 3 divided by minus 3, and then minus, and here we are going to apply the rule of the sandwich. So it's going to be minus 7 over 9. So that is the value of b. Okay, so what we have done is calculate the values of a and b. Because now we know what is the value of a and b, then my particular solution, so this is a part, my particular solution turned out to be minus 4 over 3x, and the value of b minus 7 over 9. Okay, so that is the method. Undetermined coefficients is just finding the coefficients of the proposed solution. So if it is a polynomial, then you propose a similar polynomial. Okay, the last thing to do here is write the general solution. So the general solution is going to be my homogeneous solution, c1 exponential minus x plus c2 exponential of 3x, and then plus my particular solution, which is this. So this becomes minus 4 over 3x minus 7 over 9. And that is the general solution. So you have here your homogeneous solution, and here you have your particular solution. And this is it, how to find the particular solution. Now, it looks easy, and yes, it does, but it has some tricks that we are going to see later. Now, what if we don't have a polynomial? What if we have another thing? Okay, next video we are going to see the next case. But keep in mind this differential equation, because we are going to use the same base. We are just changing the q of x, okay? See you in the next video.